Let's talk about dot product. So, what is a dot product? I'll write that down up here. Dot product. So, a dot product is something that you do between two vectors. So, I'll write an example. Let's say that you have vectors 1, 1, and 2 dot. And just keep in mind, I don't know if you've covered this yet, but when you ever have a vector that has three variables like x, y, and z, the math is all the same whenever you're doing anything related to it, like multiplying a vector by scalar. If you do 3 times 1, 2, this would still be the same way you would do it as 3 times 1, 1. You would still just distribute the 3 along every single number inside of the vector. So keep in mind, whenever you have three-dimensional vectors, same thing, all the math is the same for two-dimensional vectors mostly. So let's say you have a dot product. Let's say you have 1, 1, 2, 3, I don't know, 4, and 5. So what a dot product measures is, I guess, how closely related are these vectors? How closely related are they? And what I mean by that is, let's say you have a vector that looks like this, and let's say you have a vector that's like this. These two are pretty damn close. But what about these two vectors? Well, the scalar number for them, or the value of your dot product, will be higher on this one comparing these two vectors because they're a lot closer than the previous vector. So it's just a way to measure how close you are to vectors. But let's go ahead and solve this. Dot product, very easy. Each corresponding point, what I mean by that is each x value, so this is x, this is y, and this is z, this is the x, y, and this is the z for this vector. All you have to do is multiply the x values by the x values, or the y values by the z values for each of the vectors. Each of them. So we do 1 times 3 here, both of the x values, and we add it. So the thing that's about dot product is that you're going to get a scalar value outside of it. So what I mean by scalar value is just a real number, a whole number. No, it doesn't have to be a whole number. It's just any real number. You're not going to get a vector out of it, right? You're not going to, when you put two vectors together and you dot it, 3, 2, right? You're not going to get something that looks like this. You're just going to get a number like 5 or 10 or I don't know, 10,000. Let's keep solving this. Y, multiply the y and the y values, 1 and 4. And then multiply the z and the z values, 2 and 5 here for these two vectors. And there you go. That's how you solve for a dot product. That is if you have the components, of course. So add all these together. 3 plus 4 plus 10. And then you get 17. So the dot product of these two vectors is, well, 17. It's pretty easy. It is honestly not that hard to solve when you are given the components. Now, what if you are given the angle between them and the magnitudes of the vector? Well, this is the formula. Let's say you have vector A. And these double lines mean magnitude, by the way. So basically just the length of the vector based on your, using the Pythagorean theorem, you can solve for the magnitude. I have a video on that. Times the, now keep in mind this dot doesn't mean dot product. This dot just means multiplication. Times the cosine of the angle in between the two magnitudes of the vectors. So let's say your magnitude, let's say you're given two vectors like this. You can also solve it like this. I'm going to still give you two vectors, but let's see. Let's have 6, 7, and 4. You know what? That's a little harder to do. Let's do 5 and 0. Let's also do, let's say, 2 and 2. Now, how these two vectors look like on the graph, and this is how I figured out the angle. Dude, are you serious? This is how I figured out the angle very fast. 5 and 0 looks something like this, and 2 and 2 looks something like this. And automatically, the reason why I chose these two vectors is because it's just easy to figure out the angle. 45 degrees in between each. So we have 45 degrees of cosine. Now we have to solve for the magnitudes of these two vectors. Right? You can just multiply each corresponding point. 5 times 2. And let's actually do that right now. Plus 2 times 0, which is equal to 0 plus 10. And this is equal to 10. So the dot product is equal to 10. But let's say you want to solve for it using this formula. Well, you have to find the magnitudes of these vectors, which is the length of these vectors right here. And you also have to find the angle between them, which we already did because I'm using a very easy two vectors to find the angle between it. But let's say that you have vector A, right? The magnitude of vector A is, let's name this vector A and let's name this vector B. Magnitude of vector A is just 5. If you just use the Pythagorean theorem on 5 squared plus 0, it just turns out to be 5. And if you use the Pythagorean theorem on B, the vector B, you get 4 plus 4, which is 8. You get the square root of 8, simplified, 2 square root. 2 times square root of 2. Now, what is the cosine of 45? We have the two magnitudes. This is equal to the magnitude. And the double vertical lines just mean magnitude, if I didn't already say that. The angle is cosine, so let's solve for the cosine of 45. The cosine of 45 is square root of 2 over 2. And if we multiply all this together, 5 times 2 square root of 2 over 2, all of this simplified turns out to be, well, 10. So you can solve it both ways. They're both the same. But the dot product is very useful when you're trying to find the angles between vectors. Now, just to recap, dot product will give you a real number, right? Or a scalar value, also known as scalar value. It will not give you back a vector. One way you can solve for dot product is just multiplying each corresponding point. So x1 times x2 plus y1 times y2 plus, and if you have a third dimension, if you're taking calculus 3, you get z1 times z2, and you just get back some real number. I think this is a symbol for real number. Or you can also solve it by getting the magnitudes and multiplying the magnitudes of each vector by the angle between the two vectors to get back the dot product. I've never written this symbol down before. I think this is the real number symbol. So dot product is not that hard. Just multiply each of the corresponding points. Very simple, but you will use it for future formulas, so really keep in touch with this. If you have any questions, put it down in the comment section.